Okay, question number 13 says, which of the following Greek symbols below have line symmetry? Yeah, I told you that I'm slightly mathematically geeky because when I blow up that kind of EX looking one, I'm thinking that it's way wider on bottom than it is on top, and then I told everybody here, relax. They want you to see that this has line symmetry going straight up and down. This has line symmetry going left to right, even though I think the bottom is larger on the bottom than it is on top. I think that's just the typeset, the font that they're using. This one right here, the little tail on the bottom, makes it so it doesn't have line symmetry. And this is not closed on top, so it doesn't have line symmetry. So just the double I there and that kind of E-looking one. Other one says, which of squares, rectangles, and trapezoids have rotational symmetry? Picture's worth 1,000 words in terms of, if I draw a square, it doesn't have to be perfect. I draw a rectangle, and I draw a trapezoid. Trapezoid is just parallel sides on one side. I've always said it's like drawing a rectangle, cut the corner off, or it could be a rectangle with two corners cut off. Now, if I want to talk about rotational symmetry, a square still shows up, so a square works. The other two don't show up yet. So at 90 degrees, the square has rotational symmetry. Let's flip it upside down. A rectangle has rotational symmetry at 180 degrees. So, on this question here, I'm going to get dizzy following along with what we're doing. There is squares and rectangles. Since this video is short, we're going to keep flying along on this. Question 15 says, graph the image of ABC over a reflection of the x-axis. X-axis is right here. Now, that's just a counting activity. I want you to take a look, and I say 1, 2, 3. 1, 2, 3. A is going to be here. B, how far am I from the axis? I'm 1 away. B is right there. C, 1, 2, 3, 4. 1, 2, 3, 4. There's C. Now, that's reflected over the x-axis. Question 16 says, reflect over the y-axis. Y-axis is right here. Reflected over, C is here. A, 1, 2, 3, 4. 1, 2, 3, 4. B, 1, 2, 1, 2. Now, you might want to be smart tomorrow, color-code it. I've actually made it so that there's two graphs there. So you're going to graph one on one graph, a totally separate one on the other graph. So I'll know for sure that you have each one identified correctly. And be prepared on question, on the very bottom, 19 and 20, you're going to have to write out your coordinates for it. Let's do this very last one, 17, 18. Translating. Anybody want to give me a definition for, what does translating mean? When we reflect over something, it gets turned about the axis so things could end up upside down. The thing that's on the right could end up on the left. Translating basically means, anybody got an idea? Lexi.
It's going to be the same shape, but you're just moving it somewhere, like over the right, over the left, up or down.
Close. Reflecting is still the same shape.
Alright, I mean, isn't it going to be pointing the same way?
Perfect. It has the same orientation. It's kind of like robotically moving. Whatever's on top is still on top. Whatever's left, right, bottom is still in the same direction. Number 17 says graph ABC after translation. 3 up, 5. No, 3 to the right and 5 up. So I just pick whatever point you want to start with. I want to go 3 to the right. 1, 2, 3, 5 up. 1, 2, 3, 4, 5. That's your new B. Now I want to go 3 to the right, 5 up. 1, 2, 3, 5 up. 1, 2, 3, 4, 5. There's your A. C, 3 to the right. 1, 2, 3. Then go 5 up. 1, 2, 3, 4, 5. Now, exactly like she said, it should be congruent. It should be same size, same shape, and it should be pointed in the same direction. That's fine. Question 18. If I take a look at 18, I need to go 1 to the left and 2 down. 1 to the left, 2 down, 1, 2. Here's A. C. 1 to the left, 2 down. Here's C. And don't panic. 1 to the left, 1, 2, 1, 2 down. I end up with B inside the other shape. They can overlap, not a big deal. So, reflecting gets things flipped over an axis. Translating slides it robotically so their shape, there's actually showing exactly the same, just moving it. And translating, you're going to have to watch your rotations on 19 and 20.